3.1, inverse functions. So we've already talked a bit about functions. So for example, I could have a function f of x equals 2x plus 3. And what does this function do? Well, it takes in an x value, so it takes in an x value, right? And then you're really just applying the order of operations, right? You would first multiply whatever x value you got by 2. So we'd multiply by 2, and that would give you 2x. And then you would go ahead and add the 3 to it, and that would be what happens when you plug in a value to f of x equals 2x plus 3. So we would add 3, and then you would have 2x plus 3. And we'd call this your y value, right? Well, inverse functions are going to take a function and go the other way, or really undo it is a better way of talking about it. So let's write this up here. Inverse functions undo a function. There we go. So inverse functions undo a function. So we would be starting with this y right here. And we'd be wanting to get back to x. So we're trying to do operations to this number that we get here to get back to this original x value. If you had to add 3, if that was the last thing you did to your x, that was you added 3, then moving backwards, we'd want to subtract 3. So you'd have y minus 3. Then the next step, we did multiply by 2. The opposite operation from multiplication is division. So if we multiplied by 2 before, to undo that, we would be dividing by 2. So we'd have y minus 3 divided by 2. So what we can say here is that the inverse of 2x plus 3 is y minus 3 over 2. So to undo 2x plus 3, I would take whatever my answer is, I would subtract 3, and then I would divide by 2. Now, we don't really like to have y's as variables, so let's talk a little bit more about notation. The way that we denote an inverse is putting a little a little superscript up here, right on top of the f that's a -1. So the inverse notation would look like this. Right? This little -1 right here denotes that it's an inverse. So the way that we would read this out loud would be f inverse of y equals, I'll just write ... but it would equal y minus 3 over 2. Now, like I was saying just a tiny bit earlier, we don't really like y's as our variable. So even though technically inverses are taking in a y value, we rewrite these with x's instead. So we would say f inverse of x equals x minus 3 over 2. So all I've done between here and here is I've just replaced the y's with x's to make it the notation that we're more familiar with. The really important thing about inverse functions is that they undo a function. They bring us back to the original value. So when I take an x value and I feed it into the function f, it spits out a y value. But if I take that y value and spit it into f inverse, it's going to give me x back, right? So you give f a value. It gives you a y value, right? You end up with this like coordinate point x comma y. So you take that y value, if you plug that y value into the inverse, it's going to give you back this original x value. So let's think about those functions that we had over here on page 1. We had f of x equals 2x plus 3. And we had f inverse of x is equal to x minus 3 over 2. If I go ahead and do f of 4, that's this guy right here. I plug in 4 for x. I have 2 times 4 plus 3. So that's 8 plus 3, which is 11. This is a y value, right? This guy right here is an x value. If we take this y value and plug it into the inverse function right here, it should spit back out this x value, the original x value. So we do f inverse of 11. So that's 11 minus 3 divided by 2. 11 minus 3 is going to give us 8. 8 divided by 2 is 4. That was our original x value. So really, this composition, right, if I said f inverse of f of 4, that's what I just did here, right? F of 4 was 11, so this would be f inverse of 11, and f inverse of 11 was 4. And look at this beautiful magical thing that's happened. When we did f inverse of f of 4, it literally just canceled the f's, and you were just left with the 4. That's the beautiful and amazing and important thing about inverse functions. So there's two mathy things I need to say here about inverse functions, and they feed off of what we just said. If you have f inverse of f of x, they cancel out and you get x. And the opposite direction, same idea. So if you take f of f inverse of x, you're going to get x back. The other mathy thing I need to say, let's say on the graph of f of x, you have the point a comma b. A is your x value, b is your y value. If the graph of f of x has the point a comma b, that means the graph of f inverse of x has the point b comma a. So every point on f, if you reverse the coordinates, that's going to be a point on the graph of f inverse of x. So let's do an example. Here we have, this is called a discrete function, so it's a function that has a definite number of points to it. This function only has 5 points in it. It's called a discrete function. And we're asked to find a few different things. We're asked to find g of 7, g inverse of 7, and g inverse of g of negative 6. So let's start with g of 7. So g of 7 is asking for the y value when x is 7. So the y value when x is 7. All right, so I'm looking here for x values that are 7. Right here, I see an x value that's 7, and the y value is 6. So g of 7 is equal to 6. That's not so bad. Looking at g inverse of 7. The important thing you need to know here is that g inverse takes in y values. So this is y equals 7, and saying g inverse of 7 is saying, give me the x value when the y value is 7. So I'm now looking for places where y is equal to 7, and that's right here, right? Y is 7 on the point 3, 7. The x value is 3, so we can say that G inverse of 7 is equal to 3. For the last one, we have G inverse composed with G of -6. Let's write that in the notation that we're more familiar with. So this is G inverse of G of -6. Now, I did say back here and here that really, if you have F inverse of F, they're just going to cancel each other out and you're going to get that inside. That's what we said right there. So this should come out to be -6. However, let's go ahead and just check it out. So we're going to start by finding G of -6. G of -6 is 8. So we have G inverse of 8 because G of -6 is equal to 8. If you have the point -6, 8, that means G of -6 is equal to 8. So I'm replacing G of -6 with 8. The G inverse part is staying. Now we're asking ourselves, when the y value is 8, because this is G inverse, so it's talking about y values, the input is a y value. So when the y value is 8, what is the x value? Well, when the y value is 8, the x value is -6. So we can say that G inverse composed with G of -6 is -6, which is what our rules told us it should be. So they really just cancel each other out, which is really neat and really important. Has a lot of really important uses in basically the rest of your mathematics career. All right, let's go ahead and do another example. So here we're given two functions, f of x and g of x, and we're asked to find f of g of x and g of f of x, and then determine whether f and g are inverses of each other. So there was a really important statement I made a few slides back, and I said that if you had f of f inverse of x, that they should cancel and give you x, and then it didn't matter which direction this was, which function was on the inside. Either way, this would happen. So what we're looking for, if f and g are inverses of each other, what should be true is that when you compose them, they should give you x both ways. So f of g of x should be x, and g of f of x should be x. If this is true, then f and g are inverses. So let's go ahead and do a little bit of composition. So we'll start with f of g of x. So g of x, let's see my pointer, g of x is -x over 6. We're plugging g of x in to f of x. So we have f of g of x is -x over 6. Now we're plugging -x over 6 into the function f. So instead of x, we're going to plug in -x over 6. So we have -6 times x, and instead of x, we have -x over 6. So the negatives multiply and cancel. You get 6x over 6. The 6's cancel, and you get x, so we're good in one direction. We'll go ahead and do the other direction, g of f of x. F of x is -6x, so we have g of -6x. Now we're plugging -6x into the function g. So instead of this little x right here, we're going to have -6x. So we have negative, now plugging in x, -6x, all over 6. These two negatives are going to cancel. We get 6x over 6. The 6's cancel. Once again, you have x. So f of g of x is x, g of f of x is x, that means that f and g are inverses of one another. So if you're given two functions and you want to figure out if they're inverses of one another, you're just composing in both directions and making sure that the result is x in both directions. Let's go ahead and do another example of that. So here we have f of x is equal to 3x plus 5 and g of x is equal to 3x minus 5. So we're going to, once again, compose functions. So f of g of x, we are hoping that when we do this that we get x out of it. So g of x is 3x minus 5. So we have f of 3x minus 5. Now we're plugging 3x minus 5 into the function f. So instead of this x right here, we're going to put in 3x minus 5. So we have 3, and then instead of x, 3x minus 5, don't forget those parentheses, plus 5. Distribute the 3, you have 9x minus 15 plus 5. So simplifying, 9x minus 10. So we didn't get x. This is not x. So we don't even need to do the other direction of the composition. We did one of the compositions, we didn't get x, so we can stop right here. We know right away that these two functions cannot be inverses of one another because one of the compositions did not result in x. So we can say f and g are not inverses of one another. So we've talked about determining whether two functions are inverses of each other, but we haven't talked about how to actually find an inverse function. So let's talk about it. Here we have g of x is equal to x minus 8 over 11, and we're going to find g inverse of x. Now, at the very beginning, we talked about this whole undoing process, and that's how we found this inverse function down here. But this is a lot more writing than we'd really want to do, right? We don't really want to write it like this every time and try to figure out the opposite operation. So we need a sleeker way of doing this. In the end, what's happening here, you plugged stuff into a function to get y. Now you want to know how to get x back. So you're really solving for x, right? This right here is equal to y, and you want to solve for x. So what we're going to do, let me get back to that page. What we're going to do is replace h of x with y, and then we're going to, oops, that is too far forward. Sorry, that is our next example. Pretend I didn't go that far. So we're going to replace g of x with y, and then we're going to solve for x. Let me write it down. Now, when you solve for x, you're going to get a function that has y as the variable, sort of like we had right back here, right? In order to get it into f inverse of x notation, to get the x as the variable, all you have to do is swap the x and the y. Oops, I keep on going to the wrong problem. Now, I guess I'll just bring it up now because there's at least one of you out there that's saying, hey, I took something similar from another teacher and they told me to do the swapping x and y first, and then you solve for y. It's the same thing, but I really don't like the implications of swapping x and y to begin with. There are situations that we're not going to run into in this particular course, but that you could run into in the future, where making the swap of x and y at first would be an incorrect move that would confuse you later on down the line. So the way that we're going to do it, we're going to replace g of x with y. So that's just, we already know that, right? G of x is the same thing as saying y. And then we'll solve for x, then we'll swap x and y. So I'm starting with saying y equals x minus 8 over 11. Now to solve for x is right here. I'm going to start by undoing the denominator. So I'm going to multiply both sides by 11 because that will cancel the 11 in the denominator. Okay. So I get 11y is equal to x minus 8. Now to get x by itself, I need to add 8 to both sides. So I get 11y plus 8, you can't combine those together, right? They're not like terms, is equal to x. You have now solved for x. We have x by itself. That's what it means to solve for x. So this is our inverse function right here. 11y plus 8 is our inverse function. So if we said f inverse of y, then the answer would be 11y plus 8. But once again, they did ask for an x, right? The question asks for an x. So all we're going to do is instead of a y, we're going to put an x. So our answer is f inverse of x is equal to 11x plus 8. And that's that. Let's go ahead and do an example that's a little bit more complicated. So we have h of x is equal to 5x over 4x minus 5. And we want to find h inverse of x. And then it says we need to state the domain and range of h inverse of x in interval notation. So this is where something really important comes into play. When you have domain and range of a function, the inverse function takes the domain and range and it just flips them. So if you have h of x, this is the domain of h, range of h. So the domain of h is the domain of h. The range of h is the range of h. For h inverse of x, the domain is the range of h. And the range, let's grab another color here. The range is the domain of h. So really, it's just flip-flopped. This is really nice, and I will tell you why. This is really nice because finding the range of a rational function is not easy. Finding the range, so telling me what y values could possibly come out of this, is a very hard thing to do. You're going to find out that it's going to be like a weird value that's, not included. Finding the domain of this is no issue. We've found domains before, but finding the range of this is a problem. However, because we have this little flippy floppy thing, and finding domain is easy, we can find the domain of h, and that's the range of h inverse. And then to find the range of h, we'll just find the domain of h inverse. Right? So if I just kind of come up here and maybe do a little bit of erasing, for h of x, the domain, let's do the domain first. I don't know if the audio just picked up my dog grunting, but my dog just made a really tired grunting noise. For the domain of this guy, we can't have the denominator equal 0, so 4x minus 5 cannot be 0. Adding 5 to both sides, 4x cannot be 5. Divide by 5, x cannot be equal to, not divide by 5, you're dividing by 4. X cannot be equal to 5 over 4. So the domain of h is negative infinity to 5 over 4, and then we just kind of pluck it out of the number line and go from 5 over 4 to infinity. And that will be the range of h inverse. Now we're going to wait to do this part for when we have the actual function h inverse. So I'm going to go ahead and erase this domain stuff because we're going to need a little bit more space than that. We're going to go and do the same steps we did back here. So replace the h of x part with y, solve for x, then swap x and y. So here we have y equals 5x over 4x minus 5. Now, these rational functions have a trick, and it's important to know this trick because this is going to come back later on in the line. Calculus, you're going to be using this trick again. So the trick with rational functions, because not the same as this had a number in the denominator, no x's in the denominator. This has an x in the denominator, and that makes things more difficult. So there's an x in the numerator and in the denominator. So trick, you always start by multiplying both sides by the denominator. So I'm going to multiply by 4x minus 5 on both sides. That looks like Beth. Both sides by denom. So now we have, I'm going to put the y out front, so y times 4x minus 5 equals 5x. The next step is you're going to distribute the y, always, when you have rational functions and you're finding inverses. This is always the algorithm you use. So I have 4xy minus 5y is equal to 5x. We're trying to solve for x here. So you're going to gather all x terms on one side, and anything that doesn't have an x in it goes on the other. So this guy right here has an x in it, and this guy has an x in it. So they need to be on the same side. It doesn't matter which side, but I always like to, I like to put my x's on the left, but it doesn't matter. If there's one that's easier than the other, you can do whichever. So move all x terms to one side and all other terms to the other. So, in this particular situation, it would be just easiest to subtract the 4xy off both sides. I'm saying that that's easiest because if I go the other direction, then I have to move 5x over here and then move the 5y over here. So it's just like an extra step there. But you could do it that way. Your answer would look slightly different, but it would be the right answer. So we now have negative 5y equals 5x minus 4xy. Once again, we're trying to solve for this x here, and now the x is in two different terms, but that's not a big deal because you can factor out an x. So I'm going to factor out an x. So I have negative 5y equals x times 5 minus 4y. And at this point, you are almost there. So let me go ahead and grab a new slide. No, yes, I'm going to grab a new slide. So let me pause it and do that real quick. All right, I went ahead and just kind of made some stuff smaller, rearranged some stuff. So here we go. We're still looking at solving for this x. We just need to divide by this leftover stuff to get the x by itself. So if we divided by 5 minus 4y on both sides, then the 5 minus 4y would cancel out. you now have negative 5y over 5 minus 4y equal to x. And you just need to switch x and y. So f inverse of y, let's just start here. F inverse of y would be negative 5y over 5 minus 4y. To make this in terms of x, you just replace that y with an x. So f inverse of x, and this isn't f, isn't it? It's h. So h, let's see if I can erase this without making a big mess of everything. All right, so h inverse of x is equal to negative 5x over 5 minus 4x. Now, I'm just going to tell you, if you went ahead and during this step right here, instead of moving the 4xy over, if you did the step, if you moved 5y to the other side and moved 5x to this side, you would probably get the answer 5x over 4x minus 5, and those are the same answer. So just so you know, if you did this on your own and you got this answer, that this one is A-okay. They are the same answer. That's what would happen if you multiplied the numerator and denominator of this guy by negative 1. So here we have h inverse of x. Now the last part is finding the domain of this inverse function, because if I can find the domain of this inverse function, then I can find the range of the original function. So we can't have the denominator equal to 0, right? So 5 minus 4x cannot be 0. Negative 4x cannot be negative 5. Dividing by negative 4, x cannot be 5 over 4. So coincidentally, and this doesn't always happen, I just didn't do a good job of choosing an example, apparently. Coincidentally, both of these had 5/4 as a value that they couldn't use. So the domain of h inverse would go from negative infinity to 5/4, union 5/4 to infinity. And then h, for its range, would be the same thing. So negative infinity to 5/4, union 5/4 to infinity. And that's that. All right, so let's do one last example, and this example will not end up having the same domain and range for h of x and h inverse of x. So here we go. So we have h of x equals negative 2x plus 9 over 6 plus 5x. We are going to do the same thing we did for the last problem. So we're starting with replacing h of x with y. And just like before, the first step is multiplying both sides by the denominator. So the denominator is 6 plus 5x. So I'm multiplying both sides by 6 plus 5x. That will cancel the denominator on the right-hand side. So we have y times 6 plus 5x equals negative 2x plus 9. Then, just like before, distribute the y. So distributing the y, I now have 6y plus 5xy equals negative 2x plus 9. There are two terms that have x's in them, right? So this guy here and this guy here have to be on the same side. This guy here and this guy here, they do not have any x's in them, so they need to be on the same side. So you have a decision to make. I like to put my x's on the left side if that's at all possible, so I'm going to move these guys. These are going to both be on the left, and these guys are going to be on the right. Now, you can't just say that and say, oh, okay, so it's now 5xy minus 2x equals 9 plus 6y. You can't just, rearrange it like that. You do have to add and subtract things to make this happen. So 6y plus 5xy, let's just rewrite it. So we can mess with it newly. So the 9 is staying on the right, so he'll stay. The 2x is going to move to the left, so I am adding 2x on both sides. Let's put that, I'll just put it right here. I can't actually combine 5xy and 2x, but I'll put it there, so these cancel. And then I am moving the 6y to the right side, and the 5xy will stay on the left. So minus 6y, minus 6y, these 6y's cancel. So the 6y's are gone. We have 5xy plus 2x, that's from right here. The negative 2x is now gone, and we have 9 minus 6y. So 5xy plus 2x equals 9 minus 6y. Right? So we moved all the x terms to one side, all the other terms to the other. Now we're going to factor out the x. So these both have an x in them, and I can factor that out. So factoring out the x, we have 5y plus 2 is equal to 9 minus 6y. The last step is to divide by the leftover stuff. The leftover stuff is the stuff that's next to the x. So this is the stuff we want to divide by. And that's so that we can get x by itself. The ultimate goal here is to get x by itself. So now we have x equals 9 minus 6y over 5y plus 2. So f inverse of y is 9 minus 6y over 5y plus 2. But replacing the y's with x's, f inverse of x is equal to 9 minus 6x over 5x plus 2. So all I did there was just replace x's and y's. So now let's talk about domain and range. Looking at this original function here, the denominator cannot be 0. So 6 plus 5x, this is for h of x here. 6 plus 5x cannot be equal to 0 for the domain of h of x. So we're doing the domain of h of x right now. Subtracting the 6, 5x cannot be equal to negative 6, so x cannot be equal to negative 6/5. So the domain would go from negative infinity to negative 6/5 union negative 6/5 to infinity. So the domain of h of x is the range of h inverse. So we can fill this in right now. So negative infinity to negative 6/5 union negative 6/5 to infinity. To find the missing stuff, so the range of h of x and the domain of h inverse of x, we just find the domain. We just find the domain of h inverse. So for that guy, the denominator is 5x plus 2. So I'm just going to write it up here. 5x plus 2 cannot be 0. So 5x cannot be equal to negative 2. So x can't be equal to negative 2/5. So the domain of h inverse is negative infinity to negative 2/5, and then we pluck that number out, negative 2/5 to infinity, and that's going to be the range of h of x. So this is negative infinity to negative 2/5 union negative 2/5 to infinity. And that's that. So I know these problems aren't the shortest thing in the world, but I promise you that one day you're going to use this algebra skill again, and you'll be very thankful that you have it. So it's an algorithm. Every time you're trying to find an inverse of a rational function, it's these steps. It'll be these steps every single time. All right, I hope you have a fantastic day, and I will see you in the next lecture video.